section 6.4, vectors and dot products. So we're going to look at a certain type of calculation with a vector, a dot product. Now, the dot product in and of itself is only a number. It's not really that useful by itself. It becomes very useful when you use it in other calculations. So finding it is really easy, but a dot product in and of itself is not all that useful. How you can apply it is useful. So a dot product of two vectors is when you take their component forms and you multiply the horizontal components and the vertical components. So vector u with u sub 1, u sub 2, vector v with v sub 1 and v sub 2. The dot product, it looks a lot like multiplication, but it's not. Okay? It looks like it, the notation looks like it, but it's not strictly multiplication. It's the dot product. So u sub 1 and v sub 1, the horizontal components multiply together. U sub 2 and v sub 2, the vertical components you add together, and then you add together to get just a single number answer. So multiplying horizontals, multiplying verticals, adding those two together. So take a look at example A, B, and C, pause the video, do those, check your answers with my completed notes. So one of the first applications of the dot product is to find the angle between two vectors. So you have a vector going this way, a vector going this way. If you want to know the angle between them, you can use this calculation. Cosine of the angle between them, so between the two vectors, is the dot product over their two magnitudes multiplied together. So there's some work you got to do before you use this formula. You got to find their magnitudes and then use those in the formula. And then when you want to find your angle, you have to do inverse cosine. So to solve for theta, doing inverse cosine of the dot product over the product of their magnitudes. So there's a lot to remember with that formula. Dot product over product of magnitudes, and then doing inverse cosine of that fraction. And then this all culminates when we're going to look at our favorite three-sided polygon. You had a moment to think. I used red. This is celebratory. Three-sided polygon. The triangle. Which, just so you know, which angle is the best to try a problem from? The triangle. That's such a bad joke, but I had to do it. Okay, so you have three vertices, 5, 8, negative 1, 2, and 9, negative 4. When you plot those 3 points, you want to then solve for all 3 sides and all 3 angles, using everything we learned so far. So there are multiple ways to do this problem, but you should get to one single answer. So once you have answers, check your answers with my complete notes online.